Okay, so the warm-up is, this is 4-2. The warm-up is just to write the table as a set of ordered pairs and then find the inverse and then map it. Okay, so you need to, I'm not going to do this with you. You're going to write the set of ordered pairs from the table. You're going to find the inverse, which is going to be the flip of all of those. And then you're mapping the inverse. So what you get from this set of ordered pairs, you're going to put into the mapping. So pause it, do the warm-up, and then keep going. We're doing equations as relations today. We're still working with domains and ranges. It's just going to depend on what pieces are given to you, and what you're being asked to find is going to change based on the question. So you just have to make sure you're really looking at the directions, look what's given to you, and then try to get it from there. So this says it gives you a replacement set. Okay, so it gives you this equation, and then it gives you a replacement set. This is asking you to figure out which of these points actually works for that equation. They're not all going to work. Okay, you have to know which of these points actually works in that equation, because they give you an entire set. They give you an x and a y, and you are going to plug this x and this y in for each ordered pair into that equation and see if it gives you a true statement or not. Okay, so for the first one, y equals, my first ordered pair, my y is -1, so I'm going to do -1 equals 2 times my x in the first ordered pair is -2 plus 3. And I just have to see, this left-hand side is already a single number, so I just leave it alone. The right-hand side, I need to get down to a single number and then decide if it's true or not. So 2 times -2 is -4. Add 3. -4 plus 3 is -1. So does -1 equal -1? Yes. So that works. So I'm going to circle this point because that's going to be part of my solution set, and we'll talk about that in a minute. Okay, but then that one works. So yes. Okay. My next point I'm going to try is -1, 3. So again, I look at my thing. I'm going to plug 3 in for y, so 3 equals 2 times my x is -1 plus 3. So the left-hand side is still just a number. 2 times -1 is -2. -2 plus 3 is 1. Does 3 equal 1? No. So that's not a true statement. So this one doesn't get to be part of my solution set. That's a no. Okay? And then I keep moving. So 0, 4 is the next point. So y equals, so 4 equals 2 times my x is 0 plus 3. 2 times 0 is 0. 0 plus 3 is 3. Does 4 equal 3? No. So that point doesn't work either. Then the last one we're checking is 3, 9. So y is 9 equals 2 times x, which is 3, plus 3. Okay, just plugging the x and the y in. So 9 equals 2 times 3 is 6. 6 plus 3 is 9. Does 9 equal 9? Yes. So this one gets to be part of my solution set as well. So we just took all of those points, plugged them in for x and y into the equation that was given to us. We found any of the points that worked, and now we're going to write what we call our solution set. Okay, so they gave you a replacement set. They gave you, this is the ones that they want you to try, and now you have to write the solution set, which are going to be the ones that actually worked. So my solution set, remember, if it's a set, it has to have the squiggly brackets, and in this solution set, you just put the ordered pairs that made your equation true, which were those, the first one and the last one. So then this is your final answer. You tested all the points. Those are the 2 that worked, and now you're done. So when they give you the replacement set with the x and the y, you just plug them in and see which ones are true. If they give you just the domain or just the range, they're no longer asking, is this true or not? They're telling you, find what makes it true. So there's going to be an x and a y. There's going to be an answer for all of these. It's not, is this true or not? It's make it true. Okay? So if you remember, domain are your x values. Okay? So these are your x values. If you look at this equation, it doesn't have an x. It has an a and a b. Well, domain is always first alphabetically, or anytime you're being asked to find something where it is going to be a domain in a range or an ordered pair, an X and a Y, and they don't have X and Y, that's okay. It's just whatever variables are first in the alphabet are always going to be your X's. So in this case, my domain are my A values, and I'm trying to find my range, okay? So all I have to do is plug these numbers individually in for A, and I find B. So B equals -3 plus 5, so B is 2. So I did this one, done. B equals -1 plus 5, so B is 4. Done. Keep going. B equals 0 plus 5, so B is 5. Done. B equals 2 plus 5, so B is 7. Done. And then the last one, B is 4 plus 5, so B is 9. Done. Now, they gave you the domain, which means your answer is going to be the range. So you're just going to say range, and you're going to list the numbers that you just got for your B values, which were 2, 4, 5, 7, and 9. Okay? You generally mimic the way that they gave you the question with your answer. So since they gave us the domain is just a list of numbers, you're going to give the range as a list of numbers. Okay? So there was no true or false here. This was just here are your domains. Find the ranges that work. So you just plug them in. Okay, this one is the same thing. Okay, this has X and Y. They give you X. If they give you X, you will always be solving for Y. They give you the X's, you're going to solve for Y. If you look at the equation they gave you, you can do this without doing any work to the equation, okay? They do show you this example and then show you how to make it a little easier. If you wanted to, you could say for the first number you're plugging in for X is -1 plus 2Y equals 10. 4 times -1 is -4 plus 2y equals 10. Add the 4 over, so 2y equals 14. And then divide by 2, so y is 7. Okay, there's one of your ranges. Now you would just have to do that 3 more times. That's perfectly fine. If you want to do it that way, you can. However, if we are always going to be solving for y, because they gave us the domain, so we're going to find the range by always solving for y. For doing that, then you're going to take the equation and solve for y to begin with, okay? I can take this and I know how to solve for a specific variable. We did that a couple weeks ago. So if I take that equation with the variables in there, so 4x plus 2y equals 10. And I want to get y by itself because I'm always going to be solving for y, so why not have it alone? I'm going to subtract the 4x over. And that leaves me with 2y equals 10 and -4x are not like terms, so I just write them down, -4x plus 10. My y is not by itself yet. There's still a 2 attached to it, so I'm going to divide by 2. Divide by 2. Y equals. On the right hand side, if you look, you can see that both of these numbers are divisible by 2. So you can pretzel it, just divide both of them by 2. So -4x divided by 2 is -2x. Drop the addition sign, 10 divided by 2 is 5. Okay, so here is this equation now where I can just plug numbers in for x and solve for y automatically. So if I did the same one I just did, I plugged -1 in for my domain over here. I'm going to do it again into this equation instead, my new one, and I'm going to see if it's easier. So y equals -2 times my first domain is -1 plus 5. Okay, -2 times -1 is 2, and 2 plus 5 is 7. I got the same answer, okay? The second way was way faster. I just had to do some legwork at the beginning, okay? This takes a little bit of time. However, now the rest of my plugging in is going to be a lot easier than it would have been originally. So it's kind of up to you. Do you want to do more work at the beginning and then make each individual problem easier, or do you want to make each individual problem longer but not have to isolate the variable at the beginning? That's up to you. But we found the range for the -1. Now I want you to pause it and find the range for 0, 2, and 4 on your own. So when you're done, you need to have a set with 4 numbers in it for your range. Okay? So pause it, find your range, and then we'll move on. The numbers that you have, so you should have ordered pairs. You can have ordered pairs, I guess is what I should be saying. So for instance, -1 was my domain and I got 7 for my range. So -1, 7 is a point on that I can graph. So -1 up 7, I can plot that point. You are going to take all of the domains and ranges, pair them together that you just found on the previous slide, and then plot the points. You are not connecting your points because it's not an equation. But did it come from an equation? Sorry. It did come from an equation because that's what we plugged them into. So since you have an equation that it came from, these points should all fit a specific pattern, okay? Because an equation is a pattern. It's not like yesterday's lesson where we just had a bunch of random points given to us. These ordered pairs came from a very specific equation, so that these points should all make a specific pattern. And then when you have all of them plotted, then you can go ahead and connect them. So on these, you are going to connect. Okay? So yes, connect them. So plot the points and then connect them. All right, this one, if you wanted, so again, you're given the domain, so you're going to find the range. So if I took my original equation, if I'm always solving for the range, that means I'm always solving for y. So I subtract that 2x over, and that gives me a -2x plus 12. And then I divide everything by 2. -2 divided by 2 is -1x plus 12 divided by 2 is 6. So I can plug all of my values into this equation and give myself a little bit easier time the rest of the way. So if I'm plugging -3 in for x, so y equals -1 times -3 plus 6. -1 times -3 is 3. 3 plus 6 is 9. So my point, my x that I plugged in was -3. The y I got was 9. So that's my answer, or my ordered pair, -3, 9. So then I can come over here and plot -3 to the left, 9 up, plot the point, and move on. So now I'm going to plug in -1 for x. So y equals -1 times -1 plus 6. -1 times -1 is 1. 1 plus 6 is 7. So my point, I plugged -1 in for x, and I got 7 for y. So -1 and then up 7. Now I'm plugging 0 in. So y equals -1 times 0 plus 6. Anything times 0 is 0. So y is 6. I plugged 0 in for x, and I got 6 for y. So 0, 6 is my point. And then I'm going to plug in 2. So y equals -1 times x is 2 plus 6. That's -2 plus 6, which is 4. I plugged 2 in for x, and I got 4 for y, so that's 2 to the right and 4 up. If you notice, this makes a line because it came from an equation, which means it fits a very specific pattern, and my pattern is that it is linear. So then I'm going to connect them. Since it came from an equation, I am able to connect those points. all the way through my graph and make a really nice line. Okay? So I found all the ranges and made points and connected them all into a nice straight line. All right, you are doing 4-2. Bye, guys.